Okay, your learning target today is to discover a formula to find the arc length for a section of a circle. And then use that formula to solve the problem. But we'll just go with the discovery of the formula because I know you can use a formula once you've got it. Okay. Saw this on the SAT, and I think because before I've taught it just as a formula and not really where it's coming from, that a lot of people missed it. So I'm going to teach it a little differently. You're going to discover this formula on your own, and hopefully it makes sense and it's something that you can go back to and say, oh yeah, this is the process I have to do. So if I don't remember the shortcut formula, at least you can get the process down. So let me start something easy. Let me give you a circle. I'm going to tell you the distance around that circle. What do we call distance around the circle? Circumference. I'm going to tell you the circumference is 12 inches. So, part A. If I had half of that circle, what would this arc length be? 6 inches. Well, if I had a quarter of that circle, what would the arc length be? Quarter would be, maybe I don't want to go too fast here. How am I going to know that that's a quarter of the circle, though? What would I have to tell you? 90. The 90. I would need that angle measure in here, correct? And here I could see it was a half because I went right through the center, making it a diameter, so cutting it in half. What if I had let's go how about 45 degrees? What could you do to tell me that arc length? You can make this quantum leap. You're going to understand the process. Then 3 over 2. 1.5 you're saying. Why? You're correct.
Because it's half of 3 is 45.
Right, because half of, okay, there's a good connection. So now I want to make it a little more, let me change one more then. I didn't realize I cut that in half. I'm going to go with one more. Let's go 60-degree angle. How could we get that? Any thinkers out there today? Yep.
Like 1/6 times 12.
Where did 1/6 come from?
60 over 360.
Exactly. He's figuring out what fraction of the circle we're working with. 180 degrees was half of the circle. 90 degrees was 90 out of 360, a quarter. You're correct. He said 60 degrees out of a full 360 is 1/6 of the circle. And then he multiplied that by 12. And we get 2. So, the process to find arc length is you need to know what fraction of the circle you're working with, and you need to know your circumference. And you multiply those two together, and you're going to have that arc length. So, in general, the arc length, without a formula in words, equals the fraction of the circle multiplied by the circumference. They will give you the circumference formula on your SAT. A fraction of a circle, well, you've just got to know a full circle is 360 degrees, and then they give you the little pi piece degree. But what if we're in radians? Things change a little bit. Things get a little bit easier. So your formula, here's the concept. It's the fraction, which is our, let's make a general circle here, where we need the angle measure, and we might know the radius or the diameter. So those are the two things we need to know in order to figure out arc length. And the letter they give arc length, I have no idea why, is S. Do I like S's? No. They tend to look like 5s unless I take my time and really make them look like an S. But the arc length formula. Well, how are we going to get the fraction of the circle? Ben just told us if we know the angle measure in degrees, what are we going to divide by? 360, because it's a full circle of 360. So it's how many degrees out of 360? If I've got 180 out of 360, that's half. If I've got 90 out of 360, that's a quarter. If I've got 60 out of 360, that's a sixth. Multiplied by, what's our formula for circumference? Pi d or 2 pi r. I'm going to use the 2 pi r. You're going to see in a minute why. So there's your formula you can use if it's in degrees. And this is what you did back in geometry, because we didn't deal in radians back in geometry. So this was our process. We cranked through a bunch of these. Okay? Well, or in trig, we're going to be dealing in radians. So if that angle is given to me in radians, I'll use a little r, because we don't have a symbol for radians. Well, I'll put a little r down there. That means maybe I'll say the word radians, so you know. How many radians in a full circle? 2 pi. Remember, all the way around is 2 pi. When I multiply by the circumference, 2 pi r, what happens? The 2 pi's cancel out. The formula gets a little easier. So the formula simplifies down to theta r, radius times radians. So before I taught this, I would just tell you this is your formula for arc length. And you could crank through them for the test, for the homework assignment, for the test, and then you forgot about what it even means. So hopefully, if you don't remember this little shortcut formula, you can remember, it's the fraction of the circle times the circumference. And the fraction is just the portion of the whole thing. The degree over 360, it would probably be degrees on the SAT. It probably wouldn't be given in radians. No. Guessing that it would be degrees, so I do want to add those two formulas to your book. And we're going to be doing area of a sector next, so I kind of want you to put them on the same page so they're there. So if there's two things we're going to be talking about eventually, you want to save one page for both of them. If you're writing tiny, it doesn't matter. So you've got your radius and your angle measure, arc length, so arc length equals fraction of the circle multiplied by the circumference. So I'm going to put both formulas down after that. So it's the degrees divided by 360 times 2 pi r or it's the radians multiplied by the radius. And then we're going to put area on this page too, on another day or two, probably Monday. Example 1. We're going to have a 218 degree sector. A radius length of 15.7. Can you find the arc length? Well, just think, it's the fraction of the circle multiplied by the circumference. So the arc length, because it's in degrees, how do I get that fraction of the circle again? 218 out of a possible full 360, and then times by circumference. 2 pi times that 15.7. And now it's just one big calculator line. Fraction of the circle times the circumference. 2 pi r. Anybody have it? We're looking at sig figs here on these ones. Looks like 3 sig figs. Jimmer?
It's about 59.7.
About 59.7 units. I didn't put a label on there. Okay, easy peasy, just straightforward. Pi over 5. Radius 12.2. Can you give me the arc length? What is this angle measure in? Radians. How do I know it's not degrees? Because there's no little degree mark. If you don't see a degree mark, that automatically has to be a radian. Now at this point, we've got options. Do you want, it's your choice. Do you want to start out at the fraction with the radians over 2 pi and then times 2 pi r? Or do you want to go just to the shortcut? I don't really know what would be best. Right to the shortcut? You sure you're going to remember that? I hesitate on which way to go here. Because that 2 pi is going to cancel out every single time. Every single time it's going to cancel out. But now this process becomes different than when it's a degree. That's what makes me hesitate a little bit. I think I want to set it up. I'm going with it. Pi over 5. We're going with fraction of the circle. What's the pi over 5 a fraction of? It's not going to hurt us to see the 2 pi's cancel out. 2 pi, not 360 this time, because we're going radians and radians in degrees, so then times by 2 pi 12.2. I think it's going to help us to see it. 2 pi's will cancel every single time, so you're just left with the radians times the radius. And then pi over 5 times 12.2 is something I don't have on my paper. 7.7. Okay. So that's knowing the angle and knowing the radius. What if you know the arc length and radius? Can you give me back the angle? Let's find out. Yeah. They're going to be sig fig answers, but again, I don't really care. Do you want to throw another one on there? What is it? 6, 7? Okay. I'm going to go 4.2 inches, 6 inches, asking for the angle in radians. Because an angle measure can be given back two ways, degrees or radians. Oh, we're just going to work backwards. We do know the S value, so we're going to start with the arc length. The arc length equals, and it's still fraction of the circle. Well, there's my theta. What do I want to put it under? What do I want to put under it if I want an answer in radians? 2 pi. So that'll be radians out of 2 pi. If I wanted degrees, I'd put 360 down here. So 2 pi is down here. And then we always got to multiply by the circumference. 2 pi 4.2. 2 pi's are going to cancel every single time, so get rid of them before you even start. So we got 6 equals theta times 4.2, or 4.2 theta. Okay, if I flip that around, because that's the only thing that's left, and they're multiplied. And now how do you solve for theta? Divide by 4.2. So about how many radians is it? We'll go 2 sig figs with the 4.2. 1.4 radians. Say the arc length here is 35.76 inches. The radius is 7.35. Can you find the angle in degrees? So we're still going to set up the arc length equals fraction times circumference. I know the arc length is 35.76. The angle this time has to be divided by 360 because we want an answer in degrees, so you want your bottom number to be in degrees. Times 2 pi times radius. And now it's just your algebra. You can do it in parts. If I was going to do this, I'd probably get rid of the 360 first. What would you do on both sides to get rid of the 360? Because this is all really just one big fraction multiplied together. Multiply by 360 first? Okay. So multiply by 360. Now you're going to have to help me out because I don't have this number down. Something obnoxious. Anybody? And you just keep that answer on your calculator for a minute. And then we've got, I'm just going to leave that 2 pi times 7.35 times theta. You don't have to get this number here, but you can. Because what do we want to do with this whole chunk here to solve for theta? You want to divide by it. Well, in order to make the calculator divide by that whole chunk, you've just got to put it in parentheses. You don't even have to put the time sign in there either, I don't believe. So if you take your last answer, just continue and hit divide, and then use parentheses, 2 pi 7.35. The calculator will do the order of operations, multiply all that out, and then divide in. So this is just learning some shortcuts on your calculator at this point, which you should be practicing. And I do have this answer, I think. 279? Yes? Yeah. I don't really, I would use the whole answer. If it was me doing it, I would just use the whole answer. You know, I wouldn't retype that, because I would have that answer sitting on my line, then I'd hit divide, and it would just take the whole thing. It wouldn't round anything. Because technically, I don't think you're supposed to round until the very end. 279? Okay. Do you want a couple today, or you want a big assignment tomorrow?
A couple today.
All right. Get some out of the way today. Three, two. Let's go. Page 119, 7 through 12. Those are all the same. Those are all the same. Oh, we'll go with it.
So when we're converting, what we're trying to find the degrees,
Yep.
it'll say if they want in degrees.
You'd have to tell you. If it wants you to find an angle, it's got to tell you what kind of angle it wants. Because there are two options.
Well, I mean, I only saw you dressed up, and when I saw Kaylee, I'm like, okay.
Oh, right.
Finish your side.
Yeah, it is.
Or, you know what I love?
Mm.
My grading calculus, it never jumps up. Like, whenever I do...
I know, I got an A on that quiz and I didn't even go up at all.
Yeah,
Oh, what'd you have before the quiz?
a 91.
What do you have after the quiz?
A 91.
What'd you get on the quiz?
47 out of 50.
Which is? What percent?
I got a 40.
95.
So it went up a smidge then.
Mine didn't go up at all. My test isn't
I don't think
graded
you did.
yet.
Oh, no, it's not graded yet.
Well, maybe if you were here and watching it.
Oh.
I took it early.
Yeah.
It's fine. As early as I can take it. Can I take mine?
Yeah.
Or, yeah. Yeah, I probably should do it now.
Yeah, yeah.
Are you checking the marking right now?
I will, yes. Oh, I gotta shut this off. Here's me still recording away.
Troy Serrano.